This is a model for 2 3/4. You'll see we have 1 whole, 2 whole, and then we have these 3 1/4 pieces, which are 3/4. So how can we use this to help us rewrite 2 3/4 as a fraction? Well, the fraction part of the mixed number, the 3/4, is in fourths. We're going to actually take our wholes and we're going to break those into fourths as well. So I'm going to just draw it. So it might not be perfect because I'm drawing it, but I'm breaking these wholes into fourths as well. Okay? So now I need to count how many fourth size pieces there are in 2 3/4. So let's look at our first whole, and I see 4 parts, right? 4 fourths. And then I know in my second whole, I have 4 more fourths. So that's then 8 fourths total. And then I have my 1, 2, 3/4, which is 11 fourths. So there's 11 fourth size pieces. So 2 3/4 is equivalent to 11 fourths. When we first looked at this, we thought of it as 2 wholes plus 3/4. But then we realized, let's take our whole and break it into fourths. And we used the fact that we knew that 4 fourths was a whole. So we could multiply this 4 fourths here times 2, right? Because we had the 2 wholes. So 4 fourths times 2, because there's 2 wholes that are split into fourths. And that's actually using the identity property of multiplication. We're multiplying by a form of 1 whole, or 4 fourths in this case. So we're not changing the value. We're just finding an equivalent form, and that's 8 fourths. So 1 whole, or 4 fourths, times 2 is 8 fourths. And then we added, right down here, we added our 3 remaining pieces that were fourths, same size parts as the fourths that were in our wholes, and we found that we had 11 fourths. So we had our 2 wholes plus 3/4 to get 11 fourths. To write this out, it would look like this. We did 2 plus 3/4, because that's how we thought of our model when we first saw it. We saw the 2 wholes and the 3/4. And then what we did was we did 2 times 4 fourths, because we took our wholes and broke them into fourths. We multiplied that twice because we had 2 wholes, plus our remaining 3/4 in the last fraction bar. So that means when we solved inside the parentheses, we knew that that was 8 fourths plus our 3/4 equals our final product of 11 fourths, written as a fraction greater than 1. We're going to use this method of multiplication to write 8 1/5 as a fraction. So our mixed number of 8 1/5, and we're going to turn it into a fraction. So when I see 8 1/5, I'm thinking of it as 8 plus 1/5. So that also is the same as 8 times 5/5, because if I have 8 wholes, I'm looking at fifths, because I'm going to break my wholes into fifths because I have the fraction of 1/5. So I'm going to take my 8 times 5/5, and then I'm going to add my 1/5 there as well. So now let's solve. Well, 8 times 5/5, I know to multiply my whole number by my numerator. So 8 times 5 is 40, and my part stays fifths. So I get 40 fifths plus 1/5 for my final product of 41 fifths. I'll write that over here so we have a little bit more space. So to review that, the reason that I multiplied my 8 times 5/5 over here is because I know that I have 8 wholes, right? And those 8 wholes are 5/5. They're the same thing, right? A whole, same as 5/5. So I'm going to figure out how many fifth size parts I have by multiplying my whole number 8 times 5/5, and then adding that 1/5 that I had from the mixed number. You're now going to try some of these problems where you take mixed numbers and turn them into fractions greater than 1.